This is one of my favorite things. This is, let's just say, my favorite thing in this unit. Integration rules. Not every topic, but this one is. Integration rules, page 10. This is good stuff. It's kind of a little puzzle. They give you certain things. You sometimes solve an equation. Hopefully you enjoyed this. Here we go. So now we're finding area under curve. We're using basically properties of integrals, properties of areas under a curve. Some of these should look very familiar as derivative rules or limits. So I'll get to that in a second. All right, here's the first rule. It's called the zero property. If I'm doing the area under a curve from A to A, so for example from 2 to 2, it's 0. Because if I'm at 2, I have a point here at 2, there's no area under a point, is what this is saying. I'm not like if I went 2 to 3, now it would be this area, right? But from 2 to 2, it is nothing. It is 0. The second one, the order property. I like this one. If you're integrating from B to A, that's equivalent to integrating from A to B, but making it negative. So you flip the order and make it negative. Let me show you an example. Hopefully that became one. Let's see. Oh, it's good. Okay, good. Here I did A to B. Here, let me. On mine here, I'm going to temporarily change this. I did A to B, so it'll be negative B to A. Okay, so here's one way to think about it. We read left to right, correct? So if I'm going left to right, A to B, watch what happens when I want to go left to right, but I want to do B to A. So I'm going to flip it upside down. Here's B. Here's B, B to A. It's now in the correct order, left to right, but now it's below the x-axis.
So it's negative.
So it's negative. So that's what this says. All you do is you change the order and make it negative, and it's equivalent. It's equivalent. You can also think of it, I'll turn it back around. You can also just think of it as just going backwards. I'm going to A to B, but now I want to go backwards, B to A. Something's got to be opposite. That's the sign. Additivity. I'd say this is the best one. Probably the most important one. Additivity, it's pretty simple actually. And I'll make an illustration here before I even say what it is. So here's A, here's B, and here's C. Okay, so once you agree that the area under the curve from A to B, right, that area, plus the area under the curve from B to C, wouldn't that be equal to the area under the curve from A to C?
Well, why break it up if you can just do the area from A to C?
Well, maybe they're just asking for only a part of it. And you have A to B and A to C, and they want B to C.
So they're going to make us do individuals for A and B, and then B and C, and then add them together and instead of just doing them.
Maybe you only know part of it. So it's just part plus part equals the whole area. It's adding for areas under a curve.
So if you get the whole and say that you found B and C and you subtract
You could
from
subtract.
the whole, you could get A and B.
Exactly. That's one of the questions.
Okay.
Now, 4 and 5 are where I said that these should look familiar to derivatives and limits. 4 is the constant multiple rule, same as derivatives and limits, that if you're doing an integral of a number times f of x, you can slide that number outside. It's like if I said do the derivative or the integral, derivative or limit, excuse me. So like to find the derivative of 3 sine x, right, do d dx. Couldn't we just bring the 3 down and then do the derivative of sine x? Okay, yes, we could. So that's the constant multiple rule. You can bring a number, a coefficient outside. This one should sound familiar as well. If you're doing the integral of 2 functions, similar, like if I did the derivative of 3 to the x plus x squared, can't I do the derivative of this one first, then plus, then do the derivative of this one? Just says do them separately. And that's what this one says. You can do integrals separately, break up into two integrals, or subtract them. Those are identical as the ones from derivatives at once. Last one is a constant, like this one. It gives you a formula if you're doing the integral of a number. So if it says find the integral of 4 from -1 to 2, it gives you a formula. It says it's C times B minus A. C is the number itself. B minus A, this is A and B. So it would be 2 minus a -1, which is 3. And so we'd have 12. Now let me show you why that works. It's because it's graphically y equals 4. From -1 to 2, is not going to be a rectangle here? It means area of the curve of 4, a horizontal line. Just a rectangle. The width of the rectangle is 4. I'm sorry, the height of the rectangle is 4. And the width here is 3. So you can always do that. I actually prefer just think about it graphically. But you could also do that they break it down this little formula. Any thoughts on those properties before we try some examples with that? Excellent. Okay. Let's look below. There we go. They give us, we don't know the functions. We don't know what f or h are. There's h there, the other three are f. But we do know the area under the curve between -1 and 1, 1 and 4, and 2 and 4 for f, and -1 to 1 for h. So we don't know the functions, but we know parts of them, and we can use the properties to find some other things. All right, so know that f and h have to be continuous functions for this to work. So number 1, integral 4 to 1. There is no 4 to 1 for f of x.
1 to 4.
We have 1 to 4 of those. So what property from above am I using?
Order.
We're doing the order property. We're flipping it.
So it's 2.
So this is equivalent to negative, and then I can flip the order 1 to 4. And then what? Yeah, it's negative of -2, which is 2. By the way, no, you do not have to write out -1 to 4. You can just write -2, or even just +2. But if you want to show some work, it'd be good, so I see where you're going with it. We flipped it, made it negative. Because also, I don't like, this makes me uncomfortable going from 4 to 1. The smaller, this is the lower limit of integration, that's the upper. You can do this, it's backwards. Yeah. Okay, so let's go on to 2, -1 to 4. There is no -1 to 4. Anybody see a way around?
But there's a -1 and a -4.
There's a 1 to a
so you
-4.
Can we say it again?
There's a 1 that starts with -1,
Uh-huh.
and there's a 1 that ends with a 4.
Yeah.
So we just add those together.
Yep. So this is equivalent, I'm using additivity, number 3. This is equivalent to the integral from -1 to 1 of f of x, plus the integral of 1 to 4 of f of x. It's basically, this is the picture, if you want. It's that original one I drew, like whatever the function is. We know -1 to 1. We know 1 to 4. So they want, They want -1 to 4, so we're just going to add them together. And they want the whole thing, so we're just adding. So this one is 5. And this one is -2.
Yep.
So we get 3.
Well,
So you just have to know what rules to use for these ones?
Yep, it's just the rules.
So we need to know the rules.
Yeah, I'd say 1 through 3 are the main new ones. Because 4 and 5 should be very similar to derivatives. 6 is optional because you're just going to be able to graph 6. But if 6 is if they just give you, where was it? Here. Property 6
oh.
from above is if they just give you a number. You can use that rule from property 6, or you can just graph it and use the geometric area. Okay, so let's finish up these 3. This is a combination. You can see the number in front of the f of x. That's the constant multiple rule. Alright, so really I can pull the 2 out and do the integral from -1 to 1 in f of x. We're also using the sum rule, which says I can do another integral. I can just break it up separately. Pull the 3 out, -1 to 1 of h of x. Again, here's where you don't have to write that. I'm just showing you, like if it was a quiz, you don't have to write this. I'm just showing you so it helps. -1 to 1 of f, that was the 5, plus 3 times h is 7. So it'll be 10 plus 21, 31. Let's finish up the last 2. 4, the integral from 0 to 1, area of the curve, of f of x from 0 to 1. Now, what you should know is, at least up till now, when we were doing this, like we saw a -1 somewhere. Right? We didn't have it exactly. We saw a 4 somewhere. There is no 0 anywhere. See that? No 0 anywhere. That should be. Did you say cut it in half? That's a good thought, and that's what students want to say on this is they go to f of x and they say, well, that's half of -1 to 1. That's the whole area under the curve, though. So if it was symmetrical, yes, we could cut it in half. But we don't know what's going on with the function. I mean, part of it, let's say 0 to 1 could be like where it's like 20. But then from -1 to 0, it was actually -15. It was below the x-axis. You see, so we don't know that it's actually symmetrical. It could, so that's when you add those, you get 5. Basically, this should clue you in. If you just don't see one, if you see a number here that's not even in any of these up here, it's probably not going to work. And that's what this one is. This one cannot be determined. You can write no solution. I'm going to write cannot be determined. It says if possible, so notice that you can write no solution or cannot be determined. Okay, last one. Integral from 1 to 2 of f of x dx. We do see a 1 up there. We do see a 2 up there, so that's good. This is one. This is the one Alex you were saying earlier. So we know. I really should just go back up to this grid here. Oh, I erased it. Darn. It's the part plus the part equals the whole. Let's see if I can get it. Half. There it is. So we know the integral from 1 to 2. I'm going to not write half here for a second. Plus the integral from 2 to 4 is equivalent to 1 to 4. Using additivity. Area of the curve from 1 to 2 plus the area of the curve from 2 to 4 equals the whole thing from 1 to 4. Agreed?
Yep.
Okay. They're asking for the area of the curve from 1 to 2. I'm going to call it x. You could leave it as the integral.
Why don't you just switch
2 to 4 is given above. It's 1. And then the 1 to 4 is given above. It's -2. So I subtract 1, it's -2. And by the way, this is another one. You didn't actually have to set it up. If you could just subtract
If
them.
you just did the thing and skip it, make that negative.
Yes, you could also do that as well.
So that's what I did.
I think I've done that before on this